So this is a question from chapter 2.1, the remainder theorem. The question, x cubed plus 7x squared minus 3x plus 4 divided by x plus 2. So to solve this, we're going to use long division. So we take the divisor and put it outside the long division. And you put the dividend inside the bracket. Now to solve this, we need to find a number that multiplies to x cubed. So we have x right here, so a number that multiplies to this is x squared. So we put that on top. And remember, when you multiply two exponents with the same base, you add the exponents, so it's x cubed. And whatever you do to the first one, you have to do to the second number. So x squared times 2 is 2x squared. Now we can put brackets around this just to make it easier. So x cubed minus x cubed gives you 0, and 7 minus 2 gives you 5x squared. Now we bring down the next number. Now we need to find a number that x can multiply to 5x squared, which is 5x. So now we do 5x times x, which is 5x squared. And we do the same thing to the 2, which is 5x times 2, which is 10x. Add brackets and subtract. 5x squared minus 5x squared is 0. Negative 3 minus 10 gives you negative 13x. Now we bring down the next number. You get negative 13x plus 4. Now we need to find a number that multiplies negative 13x to x, which is just negative 13. So we put this on top. Negative 13 times x gives you negative 13x. And now we do negative 13 times 2 and it gives you negative 26. Add your brackets and subtract. That cancels out, and 4 minus negative 26 gives you 30. And therefore your remainder is 30. Now if the question asks to write the answer in quotient form, you write your dividend, which is x cubed plus 7x squared minus 3x plus 4 over your divisor, which is x plus 2, equals your quotient, which is what you got on top here, x squared plus 5x minus 13, plus your remainder, which is 30, and over the divisor again. And to check your answer, you can just simply multiply the divisor by your quotient and add the remainder. So you get x plus 2, x squared plus 5x minus 13 plus 30, which equals, so we're just multiplying, expanding the brackets, which gives you x cubed plus 5x minus 13x plus 2x squared plus 10x minus 26 plus 30. Now we simply simplify this and you get x cubed plus 7x squared minus 3x plus 4, which is the answer at the top.
I'll be doing an example of using the factor theorem. So this is a question that I have. F of x is equal to x to the power of 4 subtracted by 4x to the power of 3 minus x squared plus 16x minus 12. So to start off, we're going to find the possible roots. And these are the roots of 12. So we have 1, 2, 3, 4, 6, and 12, all positive and negative. So normally you'd go in and substitute each number in for x and solve for whichever number that gives you 0. I've already done this just to save time, so the root is x minus 3. And I'm just going to verify this with you guys. So we have f of 3 is equal to 3 to the power of 4 minus 4 multiplied by 3 to the power of 3. So 3 squared plus 16 times 3 minus 12. And this gives you 81 minus 108 minus 9 plus 48 minus 12. And this gives you 0. So now that we know for sure that x minus 3 is one factor, we can use division to find the other three factors. I'll be using synthetic division in this example. So just set it up. So we have 1, negative 4, negative 1, 16, and negative 12. This just goes down, multiply, add, multiply, add it, multiply, add it, and this just gives us x. So now we have one factor, which is x minus 3, and this gives us another polynomial. So x to the power of 3 subtracted by x squared minus 4x plus 4. So now we can't factor this further, we're going to do division again. So find the factors of 4 this time. The possible roots are 1, 2, and 4, all positive and negative. 1 works. So just to test it, we have f of 1 So I just substituted 1 into the equation for all the x variables, and then just solve this. So we have 1 minus 4 plus 4, and this gives us 0. So now that we know that x minus 1 is a root of this, we're going to use division again to solve for the other roots. I'm going to use synthetic once more. So 1, negative 1, negative 4, positive 4. Bring this down, multiply, add it, multiply, bring that down. You multiply and you get negative 4, and this just gives you x. So this is once again is another factor, so we already have this, x minus 1. And the polynomial that we get, it's x squared plus 0x, because this is 0, minus 4. The 0x just cancels out, so we are left with x minus 1, x squared minus 4. And this just turns into x minus 1, x plus 2, and x minus 2. And also don't forget this root that we had up here, and you can just bring this down as well. So our factors are x minus 3, x minus 1, x plus 2, and x minus 2. So there you go. These are your roots.
Okay, so you have to use the remainder theorem to determine the remainder for f of x equals x cubed plus 2x squared take away 3x plus 5 when divided by x plus 1. So since x plus 1 is a factor, x equals negative 1 would be a root. So you would sub in f of negative 1 into the equation to determine the remainder. So the remainder is 9. And to verify your answer, you have to use long division to see if that actually is the remainder. So we still have the remainder of 9. So therefore, when f of x is divided by x plus 1, the remainder is 9.
So equation is x squared negative x negative 6 is greater than 0. The first step is to factor the polynomial and find the 0 of the polynomial. X squared negative x negative 6 is equals to 0. Now factor them. Since we are looking for the region where graph is below x-axis, the solution set is negative 2 greater than x and greater than 0, which is negative 2 or 3. So plot the points negative 2 and 3 on the x-intercepts.
So 2.6, factoring, solving factorable polynomial inequalities algebraically. So the example is 2x cubed plus 3x squared minus 2x minus 3 greater than or equal to 0. So in order to solve this, you need to first find the factors of 3. So it'll be plus or minus 1, plus or minus 3. And then you take the factor of 3 and you make the denominator 2, so it'll be plus or minus 1 over 2, and then plus or minus 3 over 2. And then you substitute the factors into the equation, and you find out when f of x equals 0. So f of x equals 2x cubed plus 3x squared minus 2x minus 3. When f of x equals negative 3, it does not equal 0. When f of x equals positive 3, it does not equal 0. And then when f of x equals negative 1, it equals 0. And this is verified. When you substitute negative 1 into the equation, you get 0. So therefore, x plus 1 is a factor. And now you need to solve for the other factors using synthetic division. So you set it up like this. And you put the equation 2x cubed plus 3x squared minus 2x minus 3 into synthetic division. And you write factor -1 on the side, and you put 2, and you insert the coefficients. 2 comes down, so it becomes 2 times -1 is -2, which becomes 3 minus 2 is 1, and then this becomes -1, so -2 minus 1 is -3, and -3 times 1 is 3, and this becomes 0. So our new equation will look 2x squared plus 1x minus 3, and the factor was x plus 1. So now we need to factor this standard equation, and in order to that, you just find the factors of, find two numbers and multiply. Multiply to give you -3 and add to give you +1. And those two numbers are 3 and -2. And then you add brackets and you factor, so x 2x plus 3 minus 2x plus 3. So 2 factors of 2x plus 3, x minus 1, and this one comes down, x plus 1 greater than or equal to 0. Now we use the interval chart to find out when f of x is greater than or equal to 0. So we write our intervals here. X is less than or equal to -3/2 because this factor is x equals -3/2. This has a root of x equals +1, and this has a root of x equals -1. So we write our roots. So -3/2 less than and equal to x less than and equal to -1, and x is greater than and equal to 1. And the factors are going to be 2x plus 3, x minus 1, and x plus 1. And then we have to find if a number less than or equal to -3/2 would be negative in this quadrant, and in this interval it'll be positive, and then if x is greater than or equal to 1, it'll be positive. So for the second factor, it's going to be negative, and then for the third, it's going to be negative, and for this, it's going to be negative and positive. It's going to remain positive. And our final 2x plus 3. And our final would be negative here, negative, and then positive. So therefore, the f of x is greater than or equal to 0 on the interval +1 to infinity, or when x is greater than or equal to 1. So this basically means that over here, the interval is going to be greater than or equal to 0 because we have a positive, and over here it's not going to work because these are negative values. So our total is going to be, so the final is going to be that f of x is greater than or equal to on the interval 1 to infinity or when x is greater than or equal to 1.